Okay, we're going to look at piecewise functions again. So we're looking to graph these. So remember, it's a piecewise because it's really three functions on one graph, and it has to still be a function. So how do we make that happen? We have to restrict the domain over here. So that's what these guys do over here. We're saying that we're using this graph, which we know makes an upside down V because it's a negative absolute value. But we're only going to use it from the x values -6 to -1. Then at -1, this graph takes over, the graph y equals 1. And that continues until x equals 3. And then at x equals 3, this graph takes over, and it's a line because that's linear, and is for the rest of the time from from 3 to infinity. So we're graphing these three pieces on the same graph, and they have to be a function. Let me show you what this looks like. So if we look over here for a second, whoops, I don't want to do that. I want to do that. I have the three graphs here on the left. Let's look at them one at a time. So, and we'll even do this. I want to better look. So this is the graph of the first one, right? And then that's that upside down V that's been shifted that we talked about. Then this is the graph of the second one. It's just a straight line, a horizontal line at 1 because it's y equals 1. And then we have this graph here, which is a line with a negative slope. If I graph all three of them at the same time, you see we kind of have a mess, and it's no longer a function. We still want this piecewise graph to be a function. They're called piecewise functions. A reminder on how you can tell if a graph is a function. If it passes the vertical line test. When you pass a vertical line test across the function, it can only hit the function once. Here it's hitting all kinds of times, 3 times, pretty much everywhere. So let's see what we can do. Well, that's where the domain restrictions come in. So for this first graph, the red one, I'll turn off the other ones, the restrictions say from -6 to -1. So I'm going to put that here in Desmos. So we did some of this this was the point of playing marble slides. I think it was the fancy brackets we had to do. So -6 less than or equal to x less than or equal to -1. So now you can see it restricts it just down to that piece. Okay? And now we can start making this thing a function. It will pass the vertical line test. So far, we're okay, right? It only hits once everywhere, so it is a function. Now, for the next equation, the domain restriction was from -1 to 3. So notice that this next one picks up at the x value where the last one left off. So in other words, the last restriction left off at -1. This one picks up at -1. So we're going to do -1 is less than x, which is less than or equal to 3. Okay, and then let's close that bracket. Oh, that didn't work. I think I can just hit a space bar to do that. Whatever. Okay, so we can see now if I turn off the red function, this one just graphs that piece. Oh, on the red function, I think I had a mistake up here. This was less than, and I put less than or equal to. It's not going to really matter on Desmos, but let's go with less than 3. And, whoops, let's see here. What just happened? That was the second one. I deleted the first one. Okay, let me retype that. So this one was from -1 less than or equal to 3. That was the second function. I deleted the first one by mistake. So the first one was h of x equals negative absolute value x plus 4 absolute value plus 6. And we had the domain restriction -6 less than or equal to x less than -1. It wasn't supposed to be or equal to. All right, so now you can see that the second piece picks up where the first piece left off. So it passes the vertical line test, right? So right here, they switch over at this x value -1, but it passes the vertical line test. Now right here, it looks like it hits twice, but that's where the open circles and the closed circles were going to come in. And you can't really see open or closed circles on Desmos. They don't do that for you. So when we graph them by hand, we're going to have to decide, do we put an open or a closed circle there? We'll talk about that in a minute. All right? And then this one was supposed to go to 3. All right, and let me move this guy up to the top again. There we go. All right, so there's our two pieces. By restricting the domain now, we have a function. And now the second function, the blue one, ends at an x value of 3, so that's where the next one's going to pick up that last function. So if I turn on that last function, I need that to stop. I need to like get cut off right here at at positive 3. So I'm going to put those restrictions on there. And it's going to be 3. And they just do it forever. So we'll say x is bigger than 3. And it never ends on that side. It just kind of goes forever. But you can see now that if I just take each piece, by doing the domain restriction, it's a function now. And again, here at this point, if both of those circles were closed at the end, it wouldn't be a function anymore. So we have to decide open or closed. But that is how a piecewise function works. How are we going to graph them by hand? We're just going to make tables with the x values that they give us, so you don't really have to decide what x values to use. So I'll show you here. This was a little review to plug in these values and see what you get for y values, but I'm going to use this space to sketch the graph. So let's say piece number 1 I'll do in red. So I'm going to make a table, and on that table, I'm going to put these x values from -6 all the way up to -1. So -5, -4, -3, -2, -1. Okay? And for these, we're not going to worry about how it shifted or anything like that. We know what x values we want to see. This is the window of the graph that we want to see. So I'm going to plug all those x values in to this equation here. And I'm going to see what I get for y and make the list right here. So that we're going to take all these x's and plug them into this and see what I get for y. So for -6, I'm going to get negative absolute value of -6 plus 4 plus 6. And you have to use the parentheses when you plug in the value. It's just helpful. A lot of you just ignore that. You just I'm not doing it, and you make mistakes. But I'm going to just remind you, you don't always make mistakes, but sometimes you make mistakes. And I think the parentheses can help with that. So I'm going to remind you to use the parentheses. All right, so now I do -6 plus 4 is -2 inside the absolute value. And then the absolute value of -2 is +2, but then there's already a negative sitting on the outside. Right, so this part here became +2, but that negative sign comes down. And then -2 plus 6 equals 4. All right, I'm not going to write out for each one all the work because I just don't have the room. You could do it on a calculator. You can do it on a separate sheet of paper. When we do one of these in class or whatever, I'll make sure to give you room on the paper. So now I'm going to just plug them in and talk through them. So if I plug in a -5 now for x up here, -5 plus 4 is -1. The absolute value of -1 is +1, but then I multiply it by this negative, so it's back to -1. -1 plus 6 is 5. Now we're going to plug in -4. Excuse me, -4 for x. So -4 plus 4 is 0. Negative doesn't matter with 0. 0 plus 6 is 6. Now we're going to plug in -3 for x. -3 plus 4 is 1. 1 times the negative is -1. And then -1 plus 6 is 5. Now we're going to plug in the -2. We're going to plug in the -2. So I plug in -2 for x. -2 plus 4 is 2. Then times the -1s, so it's a -2. And then -2 plus 6 is 4. Okay, carrying on. Now we plug in the -1 here. -1 plus 4 is 3. And then the absolute value of 3 is still just 3, but then times the negative is -3. -3 plus 6 is a +3. All right, so now we're going to graph these. On the endpoints, though, you have to check, do you include the endpoint in your graph or not? What's going to tell you that is or equal to. So for this graph, we are going to include the point at -6. So this point right here, whoops, that was the pointer. This point right here is going to be a closed circle. So -6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Closed circle. -5, 5. -4, 6. -3, 5. -2, 4. Whoops, right there. And -1, 3. And I have to decide, is that going to be open or closed? So I look at this guy here, because you always got to check on the first and the last one of each table, open or closed. So this one's closed, and this one is open. How do I know it's open? I know it's open because of this symbol right here. We're not including the -1 point on this. So we put a dot. We still have to put the open circle here because the graph has to run right up to that point. I remember that's what we saw on our Desmos graph for that first part. Where's Desmos? Right? There's that red part right there. We'll do the second part in blue. So now we're going to graph this line. So you need a table of values from -1 to 3. -1, 0, 1, 2, 3. Now we're going to take and plug these x values into this equation. Well, if there's no x to plug it into, that's a constant function. That means the y value is just always 1, no matter what x you plug in. So we've got 1, 1, 1, 1, 1. So that's easy. Now we got to check these endpoints. Do I include or not include? So these are both open. I'm sorry, they're not both open. This one is open because it does not include. So the first -1 value, that's going to be an open circle. I usually put like a hollow circle. And then this second one here at an x value of 3, that's going to be a closed circle. So it's included. So -1, 1 is right here, and it's an open circle. And then we have 1, 1, 1, and we stop at 3 right there. And that's a closed circle. So there's that middle piece. And let's confirm with our graph. You can see that middle piece there. And again, Desmos doesn't show you those open or closed circles. And now we'll do the last one in green. So now we're using this function here. And we're starting at 3, and it goes forever. So we'll just do like 3, 4, 5, 6, maybe 4 points. I have to plug these values in. So when I plug in 3 for x, 3 times -1/2, well, that's a negative number, and then that's going to be -1.5. 6 minus 1.5 is 4.5. Now we're going to plug 4 in for x. 4 times -1/2 is -2. -2 plus 6 is 4. Now we're going to plug in 5. When I plug in 5, I get a decimal because 5 times 1/2, I don't like it. So we're going to skip 5. 6. If I plug in 6, 6 times -1/2, I get -3. -3 plus 6 is 3. So let's graph those points. Oh, and we need to see if they're open or closed. Now this table goes forever, so we don't have to check this. That's not the end of the thing. We just have to check the first one at 3. Well, it's open because it doesn't have the or equal to, so that's open. So 3, 4.5. So 1, 2, 3, 1, 2, 3, 4.5, and it's open. And then we're going to plot the point 4, 4. Then I skipped over 5, and we can graph the point 6, 3. 1, 2, 3, 4, 5, 6, 1, 2, 3. The reason I skipped it is because I know that's just a line. So I don't need every single point. Once I have 2 points, I'm good. I could draw the line, and it goes forever. So we put the arrows. Okay? So now we have to talk about the domain and the range. So the domain looks like it stops on the left side. It doesn't go forever. So our domain is right here. The leftmost side is right there, which is 1, 2, 3, 4, 5, 6, negative 6. On the right side, it goes forever because of this arrow. It just keeps going more and more right. So the domain is going to be negative 6, and it's a closed circle. Right, closed circle. So I include it, negative 6 to infinity on this side because it goes forever. The range, let's do the range in purple. The lowest value, so I'm going to erase domain so it's not as, this doesn't look as confusing. Okay, and can you come in, please? Closer? Closer? Okay, what's up?
We were going to ask if order mattered. Like
For the Y's, it does when you have to do two things.
Okay.
It does.
So would we just like combine them and then do it, or?
Can you give me 40 seconds?
Yeah.
All right, so let's look at the range here. You're in the video. Do you want to say hi?
Oh, hey.
So for range, we're going to look at the lowest value. So it looks like this arrow means it goes down forever. So it just keeps getting lower and lower and lower. So it's negative infinity. And the highest value is here. And there's no arrows that point upward. So that's 1, 2, 3, 4, 5, 6. So it goes from negative infinity to 6, it looks like, for the range. Negative infinity to 6. And it is a closed circle right there. So we include the 6. All right. So you're going to have to finish this for homework. I want you to do number 2 on your own. You don't have to do this part, but I want you to try to graph it with tables, how I did. Make a table for each one of these. It's very similar to the one we just did above, so you should be fine. I'll be collecting this. Make sure you have it done.